Hello, my name is Colin Greatwood, Mechatronics Technology Engineer with Festo, and today I'm here to show you how to use a robot-mounted Festo Vision Sensor, SBSA Vision Sensor, mounted to a UR3e collaborative robot using a Robotique collaborative gripper and adapter plate for a standard base eye calibration. We'll start with logging into the Vision Sensor using the Vision Sensor Device Manager. Now configuring the standard job. You can see here that we have a clean view of the 100mm calibration grid using lowercase job1. We'll auto set the working distance and shutter speed. Once the working distance has been set, it cannot be changed for the rest of the calibration. The shutter speed can change to create the greatest contrast required. I also have the trigger mode set to trigger. My internal illumination turned off. I'll not be using multi-shot or pre-processing today, and the calibration is preset for the 100mm grid, and we'll come back to that in a moment. We're not using the alignment tab, and from the detector tab, we have a contour tool set up. In order to edit the contour tool, we'll slide a white sheet of paper with a single part in the center of the field of view underneath the camera. We'll trigger a few images and then adjust the part as needed to get it to the center of the field of view for teaching the pattern. I'll unlock the contour and edit its taught contour by removing all, zooming out so I can see the whole pattern, and then adding pixels back in using a 50 pixel line. You can see here that I'm optimizing my taught pattern for the black to white transition from the black part to the white paper background. For standard operation, you might want to be more specific and tailor your lighting, but today I'm just using ambient to show the calibration robustness. I'll press OK and lock that contour in. I might increase the threshold to make it a little more robust and optimize my contour further. From result offset, you can see that I'm going to reset everything back to 0mm. This finds the default center of gravity of the pattern taught. I'll adjust this for where I suspect the tool center point of the gripper will need to pick. You can see based on the red region where I expect my 2 finger pads from the Robotique gripper to pick the part. I'll adjust and rotate the offset to my pattern so that it almost overlaps where I expect the TCP of the gripper to be. I'll fine tune this as best I can. I'm only looking for one object, so I don't need multiple objects. Next, I'll go to the Output tab, enable the Ethernet interface, pull in the standard telegram shown here with overall result as result 1 and then pose 3D as result 2 from that contour tool. Then I'll go back to job and make sure that trigger is set for the trigger mode. And now we'll set up to finish that calibration. I'll remove the part so the 100mm grid is shown again. And now I'll set my 4 world coordinates. First by enabling the base feature and jogging the closed gripper down to just above the calibration grid. Now I'll use my slowed down move screen to jog the robot just over the paper to fiducial 1 of my calibration grid. I'll fine tune this as best I can. This is aligning the TCP of my gripper with fiducial 1. Once I'm there, I'll take a look at my tool position X and Y shown here with base feature selected, and I'll copy those over to the Vision Sensor configuration to World X1 and World Y1. Now I'll repeat that for the second fiducial. by jogging the robot over to fiducial 2, fine-tuning as needed to get my TCP of my gripper just over top of fiducial 2. Once I'm there, I'll look at my tool position X and Y here on the move screen with base features selected and input that to world X2 and world Y2 on the vision sensor side. Next, I'll jog my robot over to fiducial 3. Slow the robot down and do my best to align the TCP of the robot with fiducial 3. Once there, look at my tool position X and Y with base features selected and type that into world X3 and world Y3. Lastly, I'll jog my robot over to fiducial 4. I'll do my best to position the tool center point just over top of fiducial 4. Once I'm there, I'll look at tool position X and Y with base features selected, and then type that in to world X4 and world Y4 on the vision sensor configuration. With a single image calibration selected and a 22mm shift in the negative direction accounting for the thickness of the part, I will return, set my trigger mode to trigger, save my job in job set, and then I'll put my sensor in start mode. Now over to the robot side. From the menu in the top right, I'll go to Settings, System, Network, and set a static IP address on the same subnet as that of the vision sensor and click Apply. This can be confirmed by going back to the device manager and seeing that it's at .1.20. My robot is now at .1.2 with the same subnet mask. Next, I'll click Load Program, load the standard program supplied by Festo for a base eye calibration. Once it's loaded, I'll go and modify that program. For SBS Connect, I'll type in the IP address of the vision sensor we just looked at, which was 192.168.1.20. Again, you can confirm that from the Vision Sensor Device Manager. Next, I'll load the basic script by navigating to my USB. Again, this is supplied by Festo. Open, edit, save, and exit. Next, I'll verify the SBS_change job I have selected. This must match exactly the job that's the active job on the configuration software, lowercase job1 in this case. Next, I will teach my image pose by jogging the camera over top of the grid, set waypoint and save. Next, I'll set up to initialize my robot by unsuppressing the initialization folder. We've already taught image pose here, but we also need to teach the gripping pose. This will set the grip plane. I'll jog my robot with fingers open and the part in the field of view now. Down, just over the part. Then I'll adjust and drive my gripper down further to approximately where I plan to pick this part. By gently holding the part in place, I'll keep it there. Open and close the gripper. You might have a small adjustment here when the gripper closes. I'll teach my gripping pose. Then I'll retract my robot out of the way and gently release the part without moving it or bumping it. It's important that the part stay where it is. Now I'll run my initialization sequence, where the robot drives down and teaches the gripping plane. Click Stop Program. Now that initialization is done, I'll suppress that folder, retract my robot back to the image pose position, and now I'll run the standard runtime program. It takes an image from image pose, drives down, and picks from the center of the field of view. After picking from the center of the field of view, I'll reset, adjust it slightly. You can see the part is shifted to the left side of the field of view. A successful pick. Now I'll adjust the other way, translating to the right side of the field of view. Again, a successful pick. I adjust to the top of the field of view, and you see how it reacts when it doesn't find a part. Adjusting back towards the center, I find it again and successfully pick from the center. Rotating aggressively about the camera's Z-axis, you can see we have a successful pick rotating from center. Thank you very much.